up on science.
From the Department of Plasma Propulsion, Professor Rod Boswell.
This is just to look at. Don't use it, because he shall not pass. What I'm going to talk about very quickly is something called CubeSats. This is an engineering structural model of a CubeSat that we at the ANU, along with UNSW in Kensington and Sydney, and the University of Sydney, are putting on the space station at the end of this year. We made it in about 10 months from scratch and a bit of money. So the total cost of our CubeSat, which is, as you can see, about the size of a loaf of bread, was about $100,000. This is not counting the cost of the time that people used, which was considerable, but about $100,000. You could have a CubeSat. And this is very important. I'm very keen on democratising as much of expensive systems as possible. And space is generally extremely expensive. If you put a communications satellite up, you're trying to put 15 tonnes up at 36,000 kilometres. The satellite's going to cost $500 million at least. And the launch is going to cost you a few $100 million. These you can probably put up for about 10,000 if you can get a launch, and that lot is about 100,000. So what is happening now is that people are finding lots and lots of really strange things they can do with this platform. So this is the 1U CubeSat. It is 10 centimetres by 10 centimetres by 10 centimetres, and fully loaded, it's about 1 kilo. That will be a fully functioning satellite. It's almost unbelievable, but that would contain a camera, GPS systems, solar panels, magnetorquers, which can then control where it points. You can actually point at a star. You can actually do astronomy with this. You do not need $500 million. To do a lot of things, you do need $500 million. But you can do lots of very small and interesting things. For example, you could have 2 of these. You could have a whole array, and as long as you can control their distance, you could have a satellite telescope in space. You can look at the distance between them. You can look at gravitational anomalies on the Earth. It's amazing what people can do. If you give people a platform, they will find a way of changing an instrument that's this big down to something that will fit in here. So this is an enabling technology, and I'm really excited about it. It is disruptive. The QB50 system, which is our satellite that's going up at the end of this year, was put forward by the European Union and not by ESA. The large groups, ESA, NASA, JAXA, etc., were not very interested in small satellites. You can't make money from $100,000. It's like selling 1 Land Rover. But it opens it for people, and it opens it for people's imagination to do lots and lots of things. So ours will go up to 350 kilometres. There is sufficient amount of air up there still that friction will bring it down in about 2 years. So, here, pass it around. You ready? Whoa! That's Ali. But people have made them, you can print them. you can do a lot, because a CubeSat goes up, it gets thrown out. Ours are going to be set out from the space station in a string of pearls, 50 of them, all the way around the world, and they will gradually descend and map out the lower thermosphere. It'll tell us about space weather, which will then be put into the Bureau of Meteorology computer systems to work out better the input of energy into the topper atmosphere. That's just one thing. There's a lot of other things. So we are really excited about this. This is the first time the ANU has gone into space. And we've done it in 10 months. I mean, is that cool or not? And there are students working on it. It's not just, you know, a whole bunch of, what was the word that you know? That was a big F word, also dickheads, in white coats. I don't use a white coat myself. Of course, I do tend to trip over me frock, but nevertheless, I could see the problem of ladies going to a ball. But I'm not sure you take your own CubeSat. So this is to show you what disruptive technology can do. There will be hundreds of thousands of these things going up in the near future, and new small companies, startups, are being created. And they will work in building these and only have half a dozen people. It will form possibilities for high-tech employment throughout the world. And it will give Australia a real chance to get back in the space race, employ people without having to have a huge space agency. So thank you.